Hello! In this series, we present some ideas on how to design and develop an industrial Internet of Things platform from the collection of industrial signals till to their processing in the cloud.
We are Giacomo Meneri and Antonio Capasso, authors of Hands-on Industrial Internet of Things, published in November 2018 by Pact. We have been working in the industrial IoT environment since 2012.
The challenge of industrial Internet of Things is to optimize the performance of industrial assets and provide tools to allow the business to take the right decision based on it. To make this real, the three profiles of automation engineer, cloud architect, and data scientist must share the same profile.
The first step is the acquisition of signals and data from the factory field. But what is a sensor, a PLC, a SCADA, or a MES system? What does real-time mean and how to get the signals that interested us? In the third and fourth chapters of the book, the industrial devices and deterministic networks, field protocols, and signal sampling are explained in detail.
The signals coming from the sensor must be transferred over the internet to the cloud. This is the role of the edge. The edge is discussed in the fourth chapter, but how to connect the edge to the industrial device without affecting their performance or putting under risk their security? The fifth chapter analyzes the critical aspect of the cybersecurity, providing secure connection scenarios for the edge.
The IoT is born with the cloud and for the cloud. However, there are also on-premises or private cloud solutions developed by OEM vendors. But what are the real advantages and disadvantages of different architectural scenarios? In the seventh chapter, the main architecture are discussed, highlighting how platforms based on microservices and containers offer high scalability and efficiency.
The chapter will implement an industrial Internet of Things solution totally based on open source technologies such as Kafka, Mosquito, Cassandra, Airflow, and Neo4j. In the following chapter, the industrial Internet of Things solution existing on AWS, Azure, Predix, and GCP are also presented in detail.
At the end of our journey in discovering the industrial IoT, there are the analytics and the tools needed by the data scientists to develop physics-based or machine learning algorithms for anomaly detection, performance evaluation, and asset or process optimization. Chapters 13 and 14 highlight the most common scenarios for analytics in the industrial IoT environment, proposing real examples of anomaly detection, residual useful life, and predictivity.
In Chapter 15, we discuss how to implement and deploy the proposed analytics on Azure and AWS. The book handles the industrial IoT using a concrete and pragmatic approach. Factory automation, cloud architecture, and data scientist scenario are analyzed and explained through real use case. Furthermore, a complete IoT exercise from the data collection to their processing in the cloud has been developed based on both open source technology and market cloud architecture.
We hope that this brief introduction has raised the same curiosity and interest about the industrial IoT that drove and inspired us to write this book. If you have the same passion, don't hesitate to contact us on LinkedIn.